So, we ditched Unity on a quest to build a VR app in C++ with some help from ChatGPT. By the way, make sure you also check out part 1 in this series if you haven't already. After the last video, we now have what we need to make a basic VR game without a commercial game engine like Unity. And when I say we, I mean me and the AI. At this point, we ride together like Marcus Burnett and Mike Lowry, like Beyonce and Jay-Z, like Kendrick Lamar and DJ Mustard. Here's what legendary Minecraft creator Notch had to say about using ChatGPT. ChatGPT is straight up useful. Direct interaction with AI to help me remain lazy is actually happening during my lifetime. Now, with the amount of work and complexity that goes into making software, programmers embrace opportunities to be lazy. That's why we continue to leverage ChatGPT to accelerate development and learning. Oh, and if you want to learn the secret to using ChatGPT effectively with code it has limited training data on, make sure you watch till the end of the video. 3D environment setup. Now, like many of you, I've always dreamed of being a ninja. So I had this idea that I'll use hand tracking to make a VR game where you throw ninja stars at a target. To become a ninja, we'll need a place to train our skills. I figured a dojo like the one from The Matrix would be nice, so I hit up Sketchfab and found one. I downloaded the GLTF 3D file, opened up Blender, deleted the annoying cube, and imported the dojo. Next, I found a pretty sweet ninja star model, a bullseye, and a torii gate model like the ones on Mount Inari in Japan. After some light work in Blender, I had a 3D scene ready for the game. The only thing missing was a background environment. In game development, often we use a 360-degree skybox image for things off in the distance to simplify the rendering. Google's physically based rendering library, Filament, supports using an environment map image in HDRI format for image-based lighting. This means that the 3D scene will be lit by the environment image. I found a Japanese forest HDR image on Polyhaven that should work for our ninja scene. Here's how the model looks in the forest lighting. We'll use Filament to load the IBL for the GLTF scene and set our environment image asset path. In OpenXR, we can use a compositor layer to render the 360 environment texture image with the highest quality. These layers don't render into the VRI buffers and get directly composited to the display. Let's add the environment composition layer. First, we decode the environment image and then we upload it to a swap chain texture. Then the code is pretty similar to when we added the augmented reality layer. Okay, so the 360 environment map is working, but it looks like I've broken texture rendering on the 3D scene. After some debugging, I think that I've isolated the issue. See, we're using the STB library to decode our images, but it looks like somebody forgot to reset the flip-on-read setting. Looks good! It's lit, so make sure you hit that like button and subscribe. Grabbing and throwing. Before we can implement throwing, we need to be able to grab the ninja star. In theory, this should be easy. In the GLTF scene, we just need to reparent the ninja star entity to be a child of the hand, and then translate the star to the location of the grab. Okay, that was random. So I asked ChatGPT to help me decompose the ninja star transform so that I can modify the world position without changing the rotation or scale. But of course ChatGPT's code didn't work correctly. So I opened up an actual computer graphics book and found the correct math needed to decompose the transform matrix. I replaced the decompose and recompose functions with the textbook math, and just like that I had support for grabbing the ninja star. One of the benefits of using a game engine like Unity is the built-in support for physics. But we don't have that, so we'll just have to do some basic physics on our own. To throw the ninja star, we'll want to track the position of the hand from the start of the grab and use the directional velocity of the hand movement to determine how the star will fly. Gravity will provide a downward force applied to the flight of the star so it will follow an arc trajectory if not thrown with enough horizontal force. I asked ChatGPT to help with the throwing logic and it provided some pseudocode to start with. With a little work, I got my first throw attempt. Let's try that again. Another one. Okay, serious this time. Yes, let's go. Sound effects. We'll need some sound effects for the throw of the ninja star and the collision with the bullseye, so I asked ChatGPT to generate boilerplate code using the Android Media Player over JNI to call Kotlin code from C++. ChatGPT was able to give almost perfectly working code this time. And just like that, we have sound effects for the ninja star throw. Collisions. To detect when the ninja star hits the bullseye, we can use the bounding boxes of the star and the bullseye to see if they overlap in world space. To debug collisions, I added some wireframe boxes to visualize the bounding boxes during the throw. Once a collision is detected, we'll stop the throw, play the hit sound effect, and the ninja star stays stuck on the bullseye. For scoring, we'll give 10 points for hitting the target and 50 points for hitting the center of the bullseye. The goal is to score as much as possible in 30 seconds. To make the game a little bit more challenging, I asked ChatGPT to provide a linear animation of the bullseye target. Since ChatGPT doesn't know much about the filament library, throughout this project there were a lot more hallucinations and bad responses. However, I figured out the secret. It was to teach the AI about filament. Whenever it couldn't generate correct filament code, I would figure it out myself and then share the code with my ChatGPT as a reference. Once I did that enough times, ChatGPT started to be able to generate working filament code. This is due to 4 features of LLMs: pattern recognition, contextual understanding, error reduction, and incremental learning. ChatGPT is kind of like having an intern that can learn fast but needs hand-holding at the beginning. It becomes a lot more useful over time. Now that the Ninja Dojo is ready, I just need to put in my 10,000 hours of ninja training to become a master. Making a VR game in C++ was actually a lot more fun than I expected. I enjoyed having a small, fully debuggable code base and none of the bloat of Unity. Some things are just simpler with direct OpenXR usage than with Unity. Iteration time was a bit annoying without a game editor. However, to use hand tracking, even with Unity, you still have to deploy to the device. Thanks for watching. Let me know in the comments what I should add to the Ninja game next. Or should I just quit C++ and go back to Unity? But don't forget to destroy that like button and hit that subscribe, and make sure you turn on the bell to catch the next episode. Peace.